Welcome to class 7 mathematics classes. Today we are going to start a new chapter, inequalities. Here we will understand about inequations, linear inequation in one variable, replacement set or universal set, solution set, and properties of inequalities. Inequations, a statement of inequality between two expressions is called an inequations. Example, 2x greater than 9. Here two expressions are 2x and 9 and it is comparing. 4x minus 3 greater than 10. Two expressions are 4x minus 3 and 10. 3x is less than 7. Two expressions are 3x and 7. 5x is greater than equal to 2 minus 3x. So here 5x and 2 minus 3x are two expressions. So this statement means 5x may be greater than 2 minus 3x or 5x may be equal to 2 minus 3x. Similarly, 6x is less than equal to 0. So this expression means there are two expressions 6x and 0. So this statement means 6x is less than 0 or 6x is equal to 0. So these are the statements of inequality. Linear inequation in one variable. A statement of any of the forms ax plus b greater than 0, ax plus b less than 0, ax plus b greater than equal to 0, ax plus b less than equal to 0, where a and b are real numbers and a is not equal to 0. It's called a linear inequation in X. So there are four forms: greater than, less than, greater than equal to, less than equal to, and a and b are real numbers. Okay, means they are constants. They are constants like 1 2 3 4 5 6. Okay, and it cannot be, a cannot be 0. If here a is 2, if this will become 0, then this quantity will become 0. Here 0 greater than 9, which is invalid statement. Okay, here this quantity will become 0. 0 minus 3 greater than 10. That means 0 minus 3 is minus 3 greater than 10, which is invalid. Minus 3 greater than 10 is invalid statement. But here 3x less than 7. So if this becomes 0, then the statement is true, 0 less than 7. Okay, but it is not always true. That is why a is not equal to 0, and it is a linear inequation in X because the variable is X, only one variable, and the power of the variable is 1. Okay, so here this kind of statements are called as linear inequation in X. Okay, replacement set or universal set. The set from which the values of the variable x satisfying a given inequality are chosen is called replacement set. And solution set, it is the subset of the replacement set. It is the subset of this replacement set, consisting of all those values of the variable x which satisfy the given inequation in X. So these two terms, replacement set and solution set, we will understand by one example. Example, find the solution set of x less than 9, where the replacement set is n. N stands for natural numbers, set of natural numbers. Okay, and natural numbers are 1 2 3 4. All the counting numbers are natural numbers. So here x belongs to natural numbers. Okay, but condition is that x is less than 9. The values from natural numbers which are less than 9 are x. Okay, so here in this manner we will write natural numbers n 1 2, this is curly bracket. So I'm writing the set of natural numbers 1 2 3 4. It goes like that. Okay, these braces are closed, or curly brackets are closed. Now x is less than 9, so all the values from natural numbers which are less than 9 are x. So this is the replacement set from where we get the values of solution set. Okay, so from here we'll get the solution set. Solution set will be equal to x belongs to natural number. This is read as belongs to, okay, x belongs to n, that is natural number, such that this is read as such that x is less than 9. Okay, so this is the condition, and we can write in other form as, if this is the condition, then what are the values? 1 2 3 4 5 6 7 and 8, not 9, because x is less than 9, not equal to 9. Okay, so the solution set is 1 2 3 4 5 6 7 8. Okay, so from this set we have taken the values of x. So this is the replacement set and this is the solution set. Okay, now few notation. N stands for set of all natural numbers, Z stands for set of all integers, Z minus stands for set of all negative integers, Z plus stands for set of all positive integers, W stands for set of all whole numbers. Okay, and these sets are written in capital letters. Okay, and natural numbers are 1 2 3 4 5 6 like this. Integers are -3 -2 -1 0 1 2 3 and so on. Negative integers are all the negative numbers. Okay, positive integers are all the positive numbers. Okay, and whole numbers starts from 0 1 2 3 4 like this. Okay, so this can be the replacement set, and from this replacement set we have to find the solution sets. Okay, now few properties of inequalities we will discuss. Number one, if a is greater than b and b is greater than c, then a is greater than c. So here suppose a is 5 and b is 4, so it is true 5 is greater than 4, and here 4, b is 4, so 4 is greater than 3. Okay, so both the statements are true. Okay, so we can write this 5 is greater than 3. Okay, it is like this only. This property says like this only. 5 is greater than 4 and 4 is greater than 3, then 5 is greater than 3. Okay, this 4 is the b here in the statements. Okay, a is 5 and c is 3. Okay, so a is greater than b and b is greater than c, then a is greater than c, then this statement is also true. If these two statements are true, then this statement is also true. Okay, 2 number, adding the same number to each side of an inequality does not change the inequality. Number 1, if a is greater than b, then a plus m is greater than b plus m. Suppose 5 is greater than 3, and if we add 1 to each side, 5 plus 1, 3 plus 1, so this will become 6, this will become 4. The sign of inequality will not change, so this statement means this only. Okay, if we add any number to each side, then the sign of inequality will not change. Okay, if a is less than b, number 2, then a plus m and b plus m will not change the sign of inequality, that is a plus m is less than b plus m. Similarly here, if we write 4 is less than 7, and if we add any number to each side of this, that is, suppose if we add 2, 4 plus 2, 7 plus 2, here 6, here 9, so the sign of inequality will not change because 6 is less than 9, so it is true only. Okay, similarly, subtracting the same number from each side of the inequality does not change the inequality. Okay, if a is greater than b, then a minus m is greater than b minus m. Like if a is greater than b, suppose 5 is greater than 3, and if we subtract 1 from each side, so here it becomes 4, here it becomes 2. So 4 is greater than 2. While subtracting a number from each side, the sign of inequality will not change. Okay, so here like this, 5 is greater than 3, so I have subtracted 1 from each side. Okay, so the values become 4 and 2. The sign of inequality is not changing. Okay, 4 is greater than 2. Similarly, if we subtract, okay, a is less than b, then the sign of inequality less than will not change. Let us examine with the same example. 5 less than 5 is less than 7, suppose. Okay, and we are subtracting 1 from or 2 from each side, so here we get 3 and here we get 5. Okay, so 3 is less than 5, this is also true. Okay, so if we subtract any number from each side of an inequality or inequation, then the sign of inequality will not change. Okay, for number, multiplying each side of an inequality by a positive number does not change the inequality. So here, if a is greater than b and m is greater than 0, okay, a positive number is represented like this. M is greater than 0, so m is a positive number. Then am is greater than bm. Suppose here 5 is greater than 3 and a positive number 2, by 2 we will multiply each side of this. So we can see the changes. 5 2s are 10, 3 2s are 6, so 10 is greater than 6. Okay, similarly, if a is less than b, then a positive number, if we multiply each side of this, the sign of inequality less than will not change, that is am is less than bm. Suppose here 5 less than 7. Okay, by 3 will multiply each side, 5 into 3 and 7 into 3. So here what we get 15, here we get 21. So 15 is less than 21. The sign of inequality will not change by multiplying each side by a positive number. Okay, 5 number, multiplying each side of an inequality by a negative number. Okay, here we are multiplying by a negative number, reverses the inequality. So here the sign changes. So this 5 number is important to remember. Okay, multiplying each side of an inequality by a negative number reverses the inequality. Number 1, if a is greater than b and m is less than 0. So by this it means that m is a negative number, it is less than 0. Then am is less than bm. Suppose here if we write 5 is greater than 3 and a negative number minus 1, okay, we'll take to multiply each side of this. So 5 into minus 1, 3 into minus 1. So here 5 into minus 1 is minus 5 and 3 into minus 1 is minus 3. So here minus 5 is not greater than minus 3. So here the sign will be minus 5 is less than. Okay, it is less than. So here the sign reverses. Okay, if we multiply by a negative integers or negative number. Okay, number 2, if a is less than b and m is less than 0, then am is greater than bm. So here also the sign of inequality changes. Okay, so suppose here 5 is less than 7. Okay, and we are multiplying by a negative number minus 2. 5 into minus 2, 7 into minus 2. What changes we'll get here? This will become minus 10 and this will become minus 14. So minus 10 is greater than minus 14, isn't it? Minus 10 is greater than 14. So the sign of less than changes to greater than. Okay, so this point number 5 is important to remember. When the negative number we are multiplying each side of the inequality, then the sign of inequality will reverse. Number 6, dividing each side of an inequality by a positive number does not change the inequality. Number 1, if a is greater than b and m is greater than 0, then a by m is greater than b by m. Number 2, if a is less than b and m is greater than 0, then a by m is less than b by m. Suppose 8 is greater than 4, and if we divide each side of this inequality by a positive number 2, 8 by 2, 4 by 2, what happens to this sign of inequality? Here we get 4, here we get 2. So the sign of inequality will not change. Another, here 9 is less than 18. If we divide each side of this by a positive number 3, so 9 by 3 here, 18 by 3. So what we get here? Here we get 3, okay, and here we get 6. So sign of inequality will not change, okay, if we divide by a positive number. Okay, 7 number, dividing each side of an inequality by a negative number reverses the inequality. Number 1, if a is greater than b and m is less than 0, this means negative number, then a by m is less than b by m. Here it is greater than. When we multiply it by a negative number, the sign reverses. Okay, similarly, a is less than b and we are multiplying by a negative number, the sign reverses here. Okay, it becomes greater than. Suppose here 8 is greater than 4, okay, and we divide each side of this by a negative number minus 2. 8 by minus 2, 4 by minus 2. Okay, so here what we get, 8 by minus 2 and 4 by minus 2, what we get here is minus 4 here, 2 ones are 2 fours are, and minus remains like this only, 2 ones are 2 twos are. Here we get minus 2. So minus 4 is less than minus 2. Okay, so the sign reverses, okay, when we divide by a negative number. Okay, similarly 9 is less than 18. If we divide each side of this by a negative number minus 3, 9 by minus 3, here 18 by minus 3, the sign will reverse here. Okay, here we get 3, okay, minus 3, and here we get minus 6. So minus 3 is greater than minus 6, isn't it? So the sign reverses here. Okay, and you know that minus 3 is greater than minus 6 because in the number line, here in the number line, 0 is here, minus 1, minus 2, minus 3, okay, and minus 4, it goes like this, minus 5, minus 6. So this is greater than this, isn't it? As it is close to 0, so that is this one is greater. Okay, but here positive number 1, 2, 3, it is increasing. Okay, here it is decreasing, the values are decreasing. This side of the 0, the values are decreasing. Okay, so here first we get -3, then we get -6, so -3 is greater than -6. Okay. 8 number, taking the reciprocal of each side of an inequality reverses the inequality. If a is not equal to 0 and b is not equal to 0, then a is greater than b, which implies 1 by a. The reciprocal of a is less than 1 by b, that is the reciprocal of b. Suppose here 5 is greater than 3, then reciprocal of 5 is 1 by 5 and reciprocal of 3 is 1 by 3. Then 1 by 5 is less than 1 by 3. Okay, this is true. So we have to remember few points where the signs are reversing. Okay, sign of inequalities are reversing. Okay, thank you very much.